Hello, my name is Darren McCulley. I'm a software engineer at SOS International, where Vue is our front-end framework of choice. Quick kind of PSA from us, we are hiring, preferably developers with Vue, Python, Golang experience for anyone looking for a job. And if you're interested, please reach out to me on the Vue DC Discord channel for more info. Tonight, what I'm going to be doing is expanding on the lightning talk I gave back in February on Rx.js. And during that talk, unfortunately, I didn't have time to cover Vue-rx, which is part of the Vue repository on GitHub and is a library that essentially helps integrate Rx.js into your Vue single file components. But tonight, we'll definitely get a chance to see that. Last time I was asked a very good question that unfortunately I did not have a very good answer for. And that question was, what's an example of a problem that you've used Rx.js to solve? I think I had a hard time answering that because outside of the little that Angular requires in order to manage async tasks, I really hadn't had a good reason to use Rx.js in a production application. But I think that actually says more about the kinds of projects I've worked on in my short time as a software engineer rather than the actual kind of utility of reactive programming. But I definitely plan to address that question tonight by building what I think is a fairly common feature for mobile applications using Rx.js. Up front, I just want to say all glory and honor for most of this code belongs to the lead developer for Rx.js, Ben Lesh, who has presented some version of what I'm about to show you dozens of times. But as far as I can tell, never inside of a Vue application, so perhaps tonight is a first, I don't know. He is also responsible for a refactor of Vue-rx in 2018 to work with Rx.js 6, which is actually going to make tonight's presentation possible, so thank you, Ben. You could find many of his talks on YouTube, and I highly, highly recommend them if you would like to learn more about Rx.js. So with that kind of plagiarism disclaimer out of the way, I'm going to start by showing you the finished product, and then we'll spend the next hour, 15 minutes or so kind of developing it a piece at a time. So what we have here, obviously, is a list of dogs, each with its own picture, a randomly chosen name, and a kind of lorem ipsum placeholder description. Special thanks to the dog API for providing an invaluable free service in these dark times, and also to Vuetify for the off-the-shelf card and loader component. This application is supposed to be see, mobile first, obviously. So hang on, just lost my pointer. There we go. So using the Chrome DevTools, I'm going to click on the kind of mobile view here, which aside from shrinking down the view, is also going to register all future click events as touch events. And what we're going to be doing essentially, if you were to open Gmail on your phone and you touch the screen with your thumb and you start to drag your finger down, you'll see a refresh icon drop into view that tracks with the movement of your finger. And if you get far enough in release, that spinner activates and an API call refreshes your inbox. So tonight we'll be building kind of a simplified version of that. So if I touch and I start to drag down, you see this component start to drop into view, and it tracks with the touch move events. And if I give up on it early and I release, it just animates up out of sight. But if I drag it down far enough, it starts to spin, triggers the refresh, and I get a new list of dogs. I have to admit that I wasted a lot of time just serially refreshing this thing over and over to see how well this random set of names actually match to the dogs in the picture. And the other thing is I take great comfort in knowing that if the rest of this presentation is a complete disaster, at least we'll all get to see a bunch of great dog photos. Let's see. So that's what we're building, and it looks easy enough. But you don't work in our field very long before you regret saying those words out loud. And sure enough, there is an awful lot to keep track of just for this kind of seemingly small feature. Ben usually prefaces this talk with it's more 300 level than 100 level, but I think you kind of need a use case like this to really showcase Rx.js. In case any part of this is hard to follow, then there are a lot of excellent resources out there that introduce Rx.js on a much gentler learning curve, including some of the YouTube videos linked here. If you were at the February meetup and saw the lightning talk, or you are already familiar with RxJS, this next part will be a little repetitive. I'm sorry for that. But for those of you who weren't or have never crossed paths with ReactiveX or its JavaScript implementation called RxJS, you could, as this introduction page suggests, just think of RxJS as Lodash for events. At the core of this library are observables and observers. And the observable class represents a stream of events to which observers can subscribe. These streams can be transformed just like arrays or any other JavaScript iterable using a long list of available RxJS operators. In many cases, the names and behaviors of these operators are already going to be familiar to you as JavaScript developers, things like map, filter, and reduce. So what is an observable exactly? An observable is a push-based set, and the keywords in that are push and set. Push, meaning we don't get values on demand like we would with a function. A promise is a good example of a push-based single-value generator. We invoke a promise, and sometime later it either resolves or it rejects. And set, meaning we could have 0 or more values to work with. Examples of multi-value generators include iterators like while loops or this dot for each up here. And unfortunately, JavaScript doesn't have a native construct that really represents a push-based multi-value generator for generic data types. There is actually a TC39 proposal to incorporate observables into the ECMAScript specification, but until the magisterium, long may they reign, see the wisdom in that proposal, we are reliant on libraries like RxJS for abstracting our application state into composable event streams. And at the bottom of this slide is an example of a marble diagram, which you're going to find all over the Rx documentation to represent observables and the effects of various operators on them. You can think of each marble as a discrete event occurring on a timeline. Marble diagrams are a great way to visualize reactive programming, and later on I'm going to show you how they can be useful for helping to select the right operator for the job. When we instantiate a new observable, we provide a subscribe function. It takes a subscriber and calls .next synchronously or asynchronously to emit new values. The subscriber has 2 additional methods we can call inside this function. Complete, which notifies the subscriber that the observable has run its course and performs any necessary teardown logic. And error, which allows the observable to raise an exception to a subscriber for proper handling. And as part of the observable contract, once either error or complete gets called, no additional values can be emitted using next. To receive values from an observable, we use this .subscribe, and inside of that is going to take 3 callbacks as arguments. The first handles any new values, the second handles the error, and the last, which is no argument, is called when the observable completes. Calling .subscribe returns a subscription, which is nice because that's going to allow us to unsubscribe as needed. So unlike Comcast Cable, the Hotel California, or native ES6 promises, you can leave and you can cancel your subscription at any time. This cancelability is actually one of the advantages RxJS has over promises for managing asynchronous events. All right, so now that we have some context for what an observable is and how you create one, let's return once again to the kind of the question of the hour, which is, why would you use one? Well, for certain tasks like animation, AJAX requests, and handling user-generated DOM events, observables allow us to model state as streams, where neither the source of that state nor the types of data carried in those streams matter. Because at the end of the day, all of those streams are just instances of the exact same observable class. And that abstraction actually turns out to be very powerful for working with async events. And it's kind of not by accident, right, that the touch drag downloader that we're going to implement combines animation, AJAX, and user-generated DOM. To get started with RxJS and Vue-rx, I kind of recommend building a sandbox project. I will often turn to these sandbox projects when I run into issues inside of kind of larger applications and I need to test some code inside of an environment with access to all of the same node modules, but without any of the application's existing baggage or bugs. So after adding these dependencies, the only other thing that you really need to do is import and use Vue-rx in main.js or wherever you prefer to call Vue.use. Before we get to work on our touch to drag load feature, I'm going to use my sandbox project to demonstrate some of the ways that Vue-rx makes using Rx.js inside of Vue single file components easier and more, I guess, Vue linguistic, for kind of lack of a better word. So let's take a look at some code. And let's quickly walk through kind of what this component does. This is a simple timer. It's going to start whenever the user clicks this start button. And during my lightning talk, I put most of my code inside of the mounted lifecycle hook. And I did so, and I've done it here again. And I did that because I needed access to a DOM element. And this is the first point, right, in the component's lifecycle that the DOM is actually available. So in the first line, we're just grabbing a reference to the start button element. And in the second line, we're using the Rx built-in constructor from event, passing it that reference to the element, the string name of the event we want to listen for to generate an observable of button clicks. When you start to work with reactive programming, you will see that it's actually common to have streams or observables in Rx end with this $sign. I recently learned, kind of as an aside, that this actually has a name. It's called Finnish notation, as in the country Finland, because the person accredited with it is from Finland, which is a terrible way to name something, even by our very low computer science standards of naming things. But anyway, you read this as clicks and ticks, but what the $sign is doing, both for yourself and for any other developer who may come across this variable later, is it's sending a message that this is a stream, or again, in the vernacular of Rx, an observable. So to get our ticks, we're going to take our stream of clicks and we're going to pipe them through a series of operators, the first of which is called exhaust map. Pipe is the method that Rx uses to apply a sequential chain of operators to any observable. You can think of it a lot like dot chaining in JavaScript, because it's essentially what it is. Exhaust map, our first operator, takes each click event and it spawns a new observable, in this case, an interval. It's another Rx.js kind of constructor, and what interval does is it will emit an incrementing counter at a fixed interval defined by the number we give it. In this case, that's 1,000 milliseconds or 1 second. And when using operators like exhaust map and switch map, we have some more terminology here. We refer to the spawning observable as the outer observable. So in this case, clicks is the outer observable, and the spawned observable as the inner observable, in this case, interval. Exhaust map has one other very important behavior, making it one of the more popular operators, and the reason you're going to see it over and over again in tonight's demo. It will ignore the outer observable until the inner observable has completed. So in practice, what that means is no matter how many times I sit here and mash on this start timer button, I'm only going to see one interval at a time. The next set of operators, we map what's coming off our interval to, which starts at 0, because that's how we count in computer science, to start at 1. So that's a pretty simple map there. And then we have tap, which kind of continues the pipe metaphor. Tap in Rx is where we do any sort of side effects. So you have access to the value of the thing inside of the stream. So you can do something like console log it, but it doesn't change that value the way that map does. Finally, observables are lazy. So just like functions do nothing until you call them, observables aren't going to do anything until you subscribe to them. So we're subscribing to ticks, and in that next callback, which is the first argument, we're assigning each value coming off the interval, or each value coming off this observer chain, to this.time, our data property, which is starting out life as a string of 3 dots, and then finally getting interpolated out in this h1. Okay, so with that introduction out of the way, let's take a look at this in the browser. So as you can see, we have our start timer button. And if I click start timer, We can see right away that map is working for us because we started at 1, and we can see that tap is working for us because we're logging values out here to the console. And then we can also see that exhaust map is working for us because no matter how many times I sit here and click start timer, I'm not generating any new intervals. I just have this one. So let's say we wanted to explore a little bit more kind of that exhaust map behavior. And in order to do that, we need to kind of cap this interval, which is just going to sit here and spam out values forever. So we just want something that's going to cap that at some finite number. And if you're new to Rx, you might wonder, well, how do I know which operator to use to accomplish this? So I head over to the Rx site, and I click on the reference tab here. The unfortunate thing is, if you've been doing this a while, you're still going to find yourself asking that exact question because there are over 190 different concepts to learn in this API. But they know that, and so they've provided this handy operator decision tree, which I'm going to click on to the left. And what this is going to do is walk you through a series of questions to help you find the operator you're looking for, or at least help you narrow down your choices significantly from 190 to say 3 or 4 that you can try. So if you think about what we're trying to do, we're trying to limit that otherwise infinite observable to some fixed number of emitted events. So the answer to this first question is, I have one existing observable, the interval, and I want to allow some, not all values to pass. And I would say, the first 5 or so. And again, not the first value, not based on custom logic, but just some given amount. The function I want is take. Great. So if I click on take, I end up at the documentation for take, which has some coding examples, a description, kind of like a type description of what take does. But more important than any of that, it has these handy marble diagrams that I showed you before. So given a source observable with events A, B, C, or D, if I apply the take2 operator, I get A, B, and then the observable completes. And that is exactly what we want to do here. So let's head back to the code and implement take. First thing I'm going to do is import it from Rx.js operators. And then you've seen this before. I'm just going to pipe interval to take, and let's say 5. If I save that, and I head back to the browser, and we start our timer, we expect this to get to 5 and stop, hopefully. Yep. And exhaust map will now allow a new click event to trigger a new interval. So I can just restart this timer over and over again. And that's exactly what we wanted to see. But there is an insidious problem here, which I also covered back in February, but I'm going to demonstrate again because it's actually a really nice segue into Vue-rx. First thing I'm going to do is get rid of the take 5 to return this back to an infinite observable. Okay. And I'm going to head back to the browser, and this toggle sandbox button up here does nothing more than vif the timer component on and off the screen. So if I start this timer and then I vif the component off the screen, you can see in the console that the subscription and the observable have outlived the component. And that's probably not what we want if we kind of created and subscribed to those observables inside of those components. So, and the danger, of course, right? I think you can see where this is going. If I start several more timers, well, you guys are kind of watching a slow memory leak live. And that's a real problem and danger. But back from the slide where I was showing how you subscribe to an observable, I talked about unsubscribe. So there is a fix for this. And in order to do it, I'm going to create a new data property called subscription. And we'll initially set that to null. And I'll set the return from .subscribe to this .subscription. And then in another lifecycle hook, appropriate would be destroyed. We will unsubscribe. All All right, let's give that a go. So I start my timer, 1, 2, 3, toggle it off, and the observable and the subscription is canceled. Great. So that's all well and good. I don't know how you feel about this code. To me, when I see this, I see a lot of Vue-related overhead to do something that's pretty simple by Rx standards. If you think about it, I've occupied lines of code inside of 2 lifecycle hooks. I have 2 data properties, one of which, if I forget, I risk memory leaks. From a component organization standpoint, all of this code would live alongside code that had nothing to do with observables or RxJS. Not a fan of that either. And it's precisely this problem that Vue-rx is going to come in to help us solve. So if I take a look at main.js, you can see that I'm already Vue.using Vue-rx, so I'm already bringing in that library. So let's use it now to sort of refactor this example and make it much less, in my opinion, intrusive. The very first thing to know about Vue-rx is that it extends the options API for Vue single file components to include a subscriptions method. Now, much like the data method returns an object containing our reactive properties, the subscriptions method returns an object containing observables we wish to make available to the component. So let's create that subscriptions method and then move the code that's inside mounted inside subscriptions. Okay, and the next thing to know about subscriptions is it's no longer necessary to explicitly subscribe to ticks the way we've done here. Vue-rx is going to take care of that for us so long as we return ticks in this object. So I no longer need this implicit subscription. Better yet, or moreover, really, the other thing that it does for you is hit implicitly unsubscribes when the component is destroyed. So by using subscriptions, I've tied the lifecycle of the subscription to the lifecycle of the component, and I no longer need the destroyed lifecycle hook, and I no longer need the subscription data property. Now, one thing you may have noticed is by getting rid of that explicit subscription, I removed the callback in which I was assigning this.time to the next value of tick. And so where would I do that? Well, the good thing is that subscriptions is actually exposing ticks to the rest of the component. So if I did something like myobs, anywhere else in the component, this.myobs is actually the latest value of what's coming off the tick stream. I personally don't prefer to have this sort of other string in here. I like the ES6 shorthand for object naming here, especially because it preserves the finish notation. And so this variable will have that $sign on it, which is a clue to any developer looking at it that it's a stream or derived from a stream. And I'm no longer assigning or using time, and instead of that, I can simply interpolate the next tick. Okay, so that looks a little cleaner. Let's head to the browser and see how that's doing. We refresh. Uh-oh, okay. Invalid event target at setup subscription from event. So what happened here is I just took a line of code that was running inside mounted that needed access to the DOM out of mounted, and I moved it into the subscriptions where it's being run too early. The DOM isn't ready yet. Fortunately, Vue-rx actually gives us, I think, a nicer, cleaner way to get a stream of DOM events using a directive that they provide called vstream. And then after the colon will be the event that you're listening for. And then after the equal sign, what we're going to supply here is the name of the observable that we want to pipe essentially this stream of click events on this button into. And the only other thing you need to do, so as much as subscriptions looks like data, DOM streams to me looks a lot like props. So DOM streams, and then you just string register clicks. And now I no longer need a reference to the DOM. I no longer need this from event. And the only thing I'm missing at this point is the keyword this for this duck clicks. Okay. Let's head back here. Start timer. And there we go. Great. The only thing I've kind of lost in translation is the starting value for ticks, which is that string of 3 dots. There are RxY ways to get that into the observable stream, but honestly, to me, the easiest thing to do is just put it right into the template. So there they are. And now what I have essentially is a component with the exact same behavior, but no lifecycle hooks, no data property, no risk of memory leaks. And really, I think the nice thing is all of my Rx code is in Vue-rx places designed for that Rx code. You know, I'll find it inside subscriptions. I'll find it in DOM streams. When I see vStream, I know what I'm looking at. So it just kind of is a really nice separation of concerns. That's pretty much the high points of Vue-rx. There are some caveats, additional API methods worth reading about, but really not worth bringing up in this presentation. So with that quick introduction out of the way, let's get to work on our drag loader. So I'll show you where we're going to begin. Let's see. Okay. I've kind of put the basic structure of the application in place to save us some time, but all I can really do right now, and I'll go back to mobile view here, all I can really do right now is refresh. Refresh the page to get a new set of dogs. I don't have that drag down to refresh loader, so I don't have any of that functionality that you saw in the finished product. We head over to the code, and we start in app.view. We look at the template. What I'm doing is I'm rendering out one of those cards for every image source URL in this array of sources. And I'm setting the source of this vimage tag to that image URL. And then really all the other if, else, this set loaded method and the loaded array are all about essentially rendering skeleton loaders instead of actual content when anything is still needing to come back. So either the API call itself or the request for the images after I get the URL. That's all that this is essentially doing. If we take a look at the JavaScript, I'm importing some constants, mainly to keep that stuff from cluttering up my Vue single file component. I have a long list of dog names to randomly select from. Excuse me, I have a mock lorem ipsum description, which you've seen a lot of. I have the API URL, and I have the number of dogs that I want to display in the list. Inside of data, I'm of course declaring my reactive properties, but I'm also instantiating them with some sort of null or zero value. And as far as making the API call for this application, I think it's appropriate to use the fetch API. And you can see in here I'm doing a couple things. I'm sort of simulating a 3-second delay. After all, we are going to be implementing a spinner, so it'd be nice to see it for more than half a second. And I am mapping the return, each dog object, just taking the dog URL and passing that to this.sources, which again is the array that's being v-forward over to generate the template. And as a side effect, I am just setting the names to a set of unique names using a recursive method, this.getName. And that's really it. And the thing that you should kind of notice here is there's not an observable in sight. If you had built this from scratch using Rx.js, you certainly would not have ended up here. But I thought it would be useful to show how to bring Rx into an existing project because we don't always have the luxury of green fields. Generally, when we're writing code, I think it's important to have some notion of the final destination in mind. I think that's truer still for reactive programming. And we know that our drag loader component will be wired somehow to our API call. And it will need both the ability to trigger the call, right, when we drag it down and hit the refresh, and it will also need to know when the call resolves so it can stop spinning and animate back home. And it's kind of at this moment, in your head when you're describing the thing or the feature you want to do, when you're faced with wiring together a set of stateful asynchronous events, that's your aha moment where you might consider using Rx.js to make the composition of those events much, much easier to manage. So step one for this, what we're going to do is replace the fetch call, which is currently returning a promise, with an observable implementation instead. What you might know is Angular's entire HTTP client is built on Rx.js, so Ajax, WebSockets, and the like, all of that is definitely in scope for this library. And the first thing I'm going to do is import a few things I'm going to need. And first of which is a method called Ajax from Rx.js Ajax. We'll define a new observable, which I'll call dog APIs, and we'll call this Ajax method, and then we're going to begin a pipeline. It's basically got to do what is happening inside this .then. So the very first thing we're going to do, let me get another import statement up here. Is map the response to get that array of dogs back. So in this sort of Ajax implementation, at this point, r.response is the actual array of dog objects. So this is the thing that I want to map. So we'll map each dog to its URL, right? And then the next thing that we want to do maybe would be some rudimentary error handler. So catch error, and given an error, let's go ahead and just console error the error. And let's return empty. Empty is an Rx.js primitive, which is essentially the observable equivalent of null. And what I'm doing here is I'm essentially saying, I'm going to guarantee that I return an observable, and then I'm going to let the subscriber decide what it wants to do in that case. Okay. And the last thing that I want to do, or actually second to last thing, I need to still simulate this set timeout. So in Rx, you don't have this sort of set timeout Christmas tree problem. You can just in inline, its version of set timeout would be delay. So this says, at this point in the pipeline, go ahead and hold off for 3 seconds and then emit the next thing. And the very last thing I'm going to do here is use an operator called share to multicast the API call. And I could stop here and kind of try to talk through what share does, but this is one of those good opportunities to actually return briefly to the sandbox and just show you what it does. So I'm going to copy and paste some code into the sandbox. And what I've pasted here is essentially another interval, which we've seen before, and I'm going to subscribe to that twice. The first subscription is going to happen immediately, and you're going to see console logs with sub1. The second subscription is going to happen 3 seconds later. So let's see what that looks like right now. So you see right here at the 3rd second, sub2 came in, but it came in with its own interval. So it's starting again at 0. And that may not be what we want. So if you don't want to invoke the observer chain again, for example, if you don't want to make 2 API requests when we could just make 1 and share that response with any subscriber who needs it, then we can use the share operator to multicast. So to fix this, I'll bring in share and I'll pipe this interval to share. And now, whoops. Now in the sandbox, when I refresh, we'll still see that same 3-second delay, but now when sub2 comes in, it's coming in with a reference to the same interval that sub1 has. Kind of a quick disclaimer about share. It's obviously useful. It's useful in this case, but it does have some performance implications under the hood. So you want to use it sparingly. Read the docs if you find yourself turning to it. But I think that preventing unnecessary API requests for the same data is definitely a good use case, in my opinion. So now that we have this observable of API responses, we need some way to trigger it. And for this purpose, Rx provides something called a subject. A subject is just like an observable with one important difference. When you subscribe to an observable, all you can really do is wait until it has a new value to provide you. Remember, it's push, not pull. But a subject has a .next method itself, which allows you to kind of imperatively trigger it whenever you need to. As you can see, fetch is called inside the created lifecycle. So we know that we're going to immediately want to make this API request when the component loads. But thinking ahead, we also know that we're going to have to respond to some sort of refresh signal from the drag loader component we plan on building. So with that in mind, let's go ahead and name our new subject, which we're going to use as a trigger, refresh. And you'll see I've used behavior subject instead of subject. Behavior subject is just an extension of the basic subject class, and I'm going to explain why. I promise I'll go back. I'm using it in lieu of subject in just a moment. But now that I have all this machinery in place, what I want to do next is go through pretty rapidly here a similar Vue-rx transformation as the one you just saw me do for the sandboxing. So once again, I'm going to begin by creating a subscriptions method. Kind of working backwards, I know that the thing that I want to replace is this sort of sources array, which at the moment is, this imperative data prop that's being set in a .then with a sources observable. So let's pretend that I have that and that exists. So that's going to be what I'm returning. If we think about where sources come from, obviously it comes from the API call, but then if we think about where the API call comes from, that's going to come from the refresh trigger. So in practice, what this looks like is refresh piped to our good friend exhaust map, which we've seen plenty now. And anytime we get a refresh signal, let's go ahead and make an API. Cool. All right. So that's great. The other thing that exhaust map is doing, just to kind of beat the dead horse on what exhaust map does, is it's going to ignore any new refresh signals until the dog API request finishes. Again, we want to prevent multiple in-flight requests, and that's why it's kind of such a popular and common operator. So before I move on to replacing this sources data prop inside the template with this kind of new sources observable, like you saw me do in the sandbox, one thing that concerns me is I'm going to lose my starting value, just like I lost the triple dots for this dot time. And this starting value here is pretty important to me, this new array of nulls, because what it's going to do is that's going to ensure that there's the right number of skeleton loaders until the API resolves. So I need some way of kind of starting life out with that every time that there's a new API call. And we're going to, in order to accomplish that, we're going to introduce two new concepts, concat and of. Now, concat takes two observables as arguments and plays the first observable to completion, and then it plays the second observable to completion. And of simply creates an observable out of whatever you give it. So let's go ahead and import those from Rx.js. And then instead of exhaust mapping to just the dog API, let's exhaust map to a concat of an observable of this new array of null concatenated with the dog API. Great. So now anytime that refresh triggers, I'm first going to start out with this numdogs length array of nulls. And then when the dog API finishes doing what it needs to do, we'll place that with the actual image source URL. So that looks pretty good. Yeah, I think the only thing left to do before checking this out in the browser is just get rid of anything we no longer need. We no longer need fetch and the created lifecycle hook. And we no longer need the sources array in data. And then we'll replace sources with its finish counterpart up here. Head to the browser, refresh. Hope that I did everything right. It's a lot of live coding. Sweet. We got dogs. Awesome. All right. So the next thing to do is to move on to the drag loader component. But I did say I'd come back to the behavior subject, and I want to do that real quick. You will notice that I said that a subject has a .next, and it's that .next that can sort of trigger a new value. I have not called .next anywhere in this code. So you might wonder what is actually causing the first API call to run. And that's why I'm using a behavior subject. So behavior subject is a different flavor of subject that when you first subscribe to it, will give you back the latest value. So if you think about it, that's why it's actually instantiated with a value. So it has to have something initially to give to anyone who would subscribe out of the gate. And so what happens is as soon as refresh is subscribed to, it is passing that null. So we're getting that uncreated lifecycle hook behavior immediately. And that's exactly why the behavior subject is being used here. All right, so we're ready to start working on the drag loader. I want to import that into app.vue and get it into the DOM, and then we can check out that. We'll register it. And we'll drop it into the DOM, say, right after the container. And let's have a look at what that kind of looks like. So to save time, I've already created the SVG and the styles that are going to center it at the top of the page, but otherwise this component is completely bare. So it's going to be a live code start to finish. Wish me luck. And let's see in the browser, there it is, in all its glory, sitting at the top of the page like we'd expect. And the next thing that I want to do is sort of create some touch event streams. If you've ever worked or implemented drag and drop, then you know that there are 3 events of interest here, essentially start, move, and stop. So let's get some references to those. I'm going to be using the familiar to you now from event method. And inside of subscriptions, once again, I'll say const touch start from event. We'll listen right to the document, and we are listening for touch start. We're going to need 3 of these, 1 for move, and 1 for end. And then I'll just return those. And after watching the vStream demonstration in Sandbox, you might wonder, well, why are you back to using from events? That kind of boils down to the fact that the element that I would want to reference is not actually available to me in this template. I might choose body or VApp. Here I'm choosing document, obviously. And rather than kind of do something sort of complex, right, like maybe add an overlay where that just whose sole purpose is to catch touch events, or maybe vStream inside of the app.vue and pass the streams down as props. Honestly, I think this is just easier. And Rx and Vue-rx are not zero sum in the way that most Vue shared state management under Vue.x or Redux. There's no thou shalt rules here. Do whatever works for you. If you need to bail out of something and just do it imperatively from a reactive solution, do it if it's working. If it makes the code work. At some point, like there's no reason to necessarily make your life harder. I'm going to tack on a pipeline to each of these. I'm going to do that with a copy and paste to save some time. And the pipelines are really just so that we can all see what's going on. So this is the initial start, and this is what it's going to look like with pipelines and some operators. And I'll quickly talk through for start and end. That's simple. That's a straightforward tap log of the event. For touch move, what pluck is doing is it's sort of shorthand for map event.touches. So it's just going to grab the value of whatever's at that key on the object that's coming down the stream and pass it along. If you're new to touch API like I was when I started this, you might wonder why I am mapping touches to touches 0. Well, when you're using a mouse, there's just a mouse, and you're not really worried about there being like 7 mice hooked up. Unfortunately, when it comes to touching a screen, for gesture clicking or whatever, of course you can have more than one finger touching. This app only cares about the first finger that's going to touch the screen, which is touches 0, and why we see that map. Then I'm plucking the Y coordinate off that and tap logging that. So let's go ahead and see what this looks like in the browser. So if I just click and release, you can see in the console, touch start, touch end. And if I click and start to move around, or just move around generally, then you can see the Y coordinates start to get printed out. And as I let go, another touch end. So that's all well and good. That's not terribly useful yet. Let's go ahead. I'm going to undo that sort of pipelining because that was only for show. So back to our kind of start position, let's compose these events into something that's a bit more useful to us. Let's call this new observable drags. And while I was console logging out the position or the Y position of our touch event, honestly, that's not what we're really interested in. If you think about it, it doesn't matter where on the screen you touch your phone to start dragging down. What we're really interested in is the difference or the change in Y, the delta Y from the starting touch position to where it ends. And that's really what we want to continue to measure until we get a touch event. So how that kind of manifests inside of Rx.js, we'll start with touch starts as our source observable. And we'll pipe that to our now good friend here, exhaust map, which you've seen several times already. And we're going to take each start event, and we're going to map it to touch moves. And we're going to pipe each touch moves into a map to get the difference. So we'll map that move event into move.touches. And you saw some of how this is constructed before in the plucking. Page Y minus start touches 0 page Y. So now we have this sort of delta Y stream of events, which is what we want. And of course, we want to take that now until a touch event. And it's a very appropriately named operator here, take until touch end. And the last thing I want to do is do another tap log. So delta Y, we'll just console log UI. And we bring in some operators up here. Tap. Okay, and instead of returning these 3 events, I'm going to return drags. And you might think, well, observables are lazy, right? So if I don't return them and I don't subscribe to them, how do these events ever, or observables ever go live? And the reason that they go live is they're part of the observable chain that makes up drags. So because touch start, touch move, and touch end all appear inside drags, the minute I subscribe to drags, I've also, by extension, subscribed to all of these. So let's go back to the browser and see if we can measure some DYs. All right, and now what we'll see here is no matter where I touch, so that was 8 to 121, if I do it down here, 8 to 80 or whatever. So it doesn't matter where I touch the screen anymore. What I'm really measuring now is the change in Y position from where I started to where I left it. And that's exactly what we want. And it turns out actually that this is really all you need to do for basic drag and drop. And seeing the machinery for drag and drop implemented in about 10 lines of code was one of the moments that I really kind of sat up and took notice of what this library could do. So now that we have everything that we need to update the Y position of the drag loader based on touch events, to perform those position updates, I'm going to be relying on CSS transformations. So what we're essentially going to do is map the delta Y coming off the wire in our drags observable to a CSS string that the template can understand that will update the position of the component. So let's call this new observable transform positions. And that is going to be derived from drags. We pipe and then map the dy to a string. Transform, translate 3D, 0, dy pixels, 0. Okay. And then instead of drags, we'll return transform positions. Don't need this extra S, I do that all the time. And just like we did before, we can bind directly to a style property here with transform positions. And this is on the outer div wrapping the SVG, so we'll move the whole thing down, hopefully. And I need my finish notation there. Okay, that looks good. Let's give that a shot. The other thing I want to do is just get rid of this tap log. I don't need that anymore. And now if I start dragging, you can see that I can move the component around the screen responsive to the delta Y of my touch event. Great. So we're pretty far down the road here. And the next step would probably be animating it back home. But before we move on to animating this component back to its starting position, I just want to fix a couple things that aren't quite right. We're not really interested in the Y position of our touch events. We are very interested, however, in the Y position of this component. So maybe it would be better to come up with an observable that represents that a little more clearly than the delta Y we've been using to sort of kind of command this movement. So I'm going to add a positions observable right down here. Whoops, here. And that will be derived from drags. And the only real difference here is I want that to start at 0. And we use an operator called start with to do that. And the loader, if you looked at Gmail, that thing doesn't live on the screen the entire time. So let's make sure that its home is 70 pixels up. And maybe Y is more appropriate. And we'll use positions as the source for transform positions. And now when we go back, what we should see is that component should no longer be on the demo. But if I start dragging down, sure enough, it's waiting right there for me to bring in a position. All right, so we're on to animations. I'm going to open a file called animation.js, where I'm exporting a class called Rx Animation Service. Things are about to get a little hand-wavy here because animation using Rx.js is a talk unto itself. But this animation.js file exists primarily to provide this tween method at the bottom. And while I'm clearly not going to code it live because it's up there in front of you now, what I do want to do is kind of go step by step and try to briefly explain what's happening, because I think it's yet another good example of what Rx can do. So if we start with this first line here, this frames observable. Starting here, we've used interval both in the lightning talk and in this talk several times already. But the thing is, we've never used it with a second argument. And what that is a scheduler. And most, if not all, of the observable constructor methods that Rx.js gives you will accept as their last argument an optional scheduler. And what a scheduler offers us is a way to introduce maybe a more complex event release schedule than whatever we would normally get out of the box. In this case, what we're after is a stream of animation frames to trigger my position updates on. So instead of emitting 0, 1, 2, every n milliseconds, this observable will emit a new value whenever the browser reports that it is able to perform a render cycle. The animation frame scheduler, which is, as you can see, being imported from Rx.js, wraps the request animation frame API on the browser to achieve this. This next section, ticks, is basically the time elapsed from when we started to the current animation frame being released. And you'll notice that it's wrapped in an Rx.js defer. This won't actually be the last time that you see defer tonight, so it's worth stopping and explaining here. And I think I can give you an idea of what defer does and why it's necessary in this case with a simple Node.js demo. So let me open terminal window, load up a little bit. So let's say we have a variable x is 1, and let's define a higher order function called printx, which is going to take in an x and return a function which is going to just log out the value of x. Okay. Now let's use set timeout to call printx with the current version of x. Maybe put it on the event loop for a second. In the same line, I'm going to overwrite the value of x to 2. So you see 2, that it was overwrited, but you see that the value of x as reported by the set timeout is 1. And the reason that that's happening is that printx is creating a closure, which is capturing the value of x at the moment that it is invoked. So if I had a way, right, to keep printx from creating that closure until my set timeout resolved on the event loop, then instead it would have printed the updated value of x. And this is essentially what defer is doing for us. It holds off on setting up the observable until something subscribes, and that can be very useful in practice. So let's return to the code and kind of take that from the top with a tick example. So just like with printx in the node example, the problem with ticks without the defer is that whatever now is at the time that the observable is created is going to be the value that it uses for start, this constant start. And that's not what we want. What we want now to be is to be the moment that the observable is subscribed to. And that's why it's wrapped in the defer. Moving on to duration. Duration is a little more straightforward. It's a function that takes a duration in milliseconds and is going to return an observable derived from ticks, so emitting on every animation frame. If you think about it, what we're looking to do is move an element from one position on the screen to another on the screen. And duration here is the time that we want it to take for that element, for that animation to complete. So first, we map elapsed time thus far into a percentage. That's the T over MS. And then we're going to take animation frames until we're at 100%. That's this less than or equal to 1. And I've added on, for precision's sake, an ends with 1 because this quotient will probably be slightly larger than 1 when the take while completes. And all of that was to construct tween. And what tween will do is it'll take a numerical start and end value along with the duration, and return an observable that emits an updated position for each animation frame based on the amount of time that has elapsed. And it's probably not obvious because I went through that pretty fast, but one of the really nice things here about Ben's approach is that there's consistency in user experience. So regardless of how busy the browser is or how janky the machine running the browser is, when we use tween to say it's going to take half a second to animate this drag loader off the screen, then it's going to take half a second, regardless of frame rate. And implementing frame rate agnostic animation in 26 lines of code is yet another kind of awesome example of where Rx really, really shines. So let's return to the drag loader, right, and use this tween method that I just showed you to send the component back home to its starting position after we're done dragging it around. The first thing I'll do is import that service. And I'll create an instance of it. And the next thing that I'm going to do, if you think about our task at hand, is to update the position, right? So I'm going to create a variable to help track the current position so that we know what to supply as the start argument to tween. So we'll say let current position equals 0. And then let's create a new observable. We'll call it return positions. Going to house the numbers that will animate our component. And this is going to be based on tween. So animation service tween. We want to go from the current position back home to 0 in, let's say, 300 milliseconds. Great. Okay. Now, how do we use it? We saw back in app.vue the use of concat, and that's what I'm going to turn to again. It's basically I want to allow the user to drag this thing around, and then when they're done dragging it, I want to concatenate on this series of return positions to say wherever this thing currently is, animate it back to 0 in 300 milliseconds. So we'll bring in concat, and we will concatenate this touch move with return positions as what we're exhaust mapping to. There we go. Now, the only other thing that I need to do is I need some way of updating that current position. And that's kind of a side effect. So it's a good use case for tap. So if I take the current DY, I can say current position is equal to DY. All right, that looks good. Let's head back to the browser and see if it works. So drag it down, a release, no, it's just disappearing. Huh. Well, the problem is that in the eyes of tween here, current position is 0 and will always be 0 regardless of this updating that's happening inside of tap. The good news is we just saw how to fix that, how to defer the sort of assignment of this variable until return positions will be subscribed to in this concat. So let's fix it with the defer. And we'll import defer. And with any luck, when I drag down and release, yay, we are animating home. And that's cool in and of itself. One thing I want to point out is if I drag down just a little bit and I let go, the velocity, the return velocity is a lot slower than if I drag all the way down and let go. And the reason for that, right, is because regardless of any other variable like frame rate or the distance that you have to travel, in tween, I've gone ahead and said, you have 300 milliseconds to get home, make sure you get there. So returning back to VS Code. The next thing that we want to do is send a signal up to app.vue to make the API call that refreshes the content. We already have tap on delta Y here in the chain So what if we just said, let's emit a refresh whenever delta y gets below, let's say, half the window height. So if dy is greater than window.inner height divided by 2, let's emit a refresh. Okay. But we need to be a little careful here because we don't want to just spam emit this refresh. We want to do this at most once. And so we can use another operator at the tail end of this entire exhaust map to basically kill this the second that we go over that line. And that operator is called take while. So we'll take these events while dy is less than or equal to window inner height divided by 2. All right, that looks good. All right, if we're going to emit something, we better catch it. So I'm going to head over to app.vue, and on a refresh, let's fetch some dogs. And the implementation of this, first and foremost, we do know how to trigger an API call. Although we haven't done it yet, but we talked about it. If I call .next on this refresh subject, that will absolutely trigger a new API call. So I want to do that, but I just want to do 2 things beforehand. I need to reset some state. I need to reset the loaded array because none of the images will have been loaded, and I need to reset this name indices set so that getName can properly function to get a new set of random names. So this dot name indices is a new set. So this is just taking our variables back to their starting state, and this dot loaded is a new array. Awesome. All right, I think that's everything we need. Let's see if we can get a new set of dogs. All right, dragging it down. All right, we are refreshing, and our component is stuck. Cool. To be honest, we actually kind of want the component to hang out, right, until the API request completes. So that's the whole point, to spin and tell the user that something's happening. But obviously something's broken. And the thing that's broken, heading back to the code, is that this take while is going to kill the entire drags observable. And right now, if I trace this all the way through, drags is feeding positions, positions is feeding transform positions. This isn't going to help us because the whole thing's dead. So there's just no way to get back home. This return positions only helps us if we let go before we get this far. So if you think about what we're going to need a way to fold the dog API events into the mix as well. So let's first start out by creating a new observable. Call this one return after load positions. And if you think about what the source observable is for this, it's whenever the API responds, with a success or failure, that's when we want to send it back home. Now, we don't really have access to that in this component yet, but nothing stops us from exporting it from app. So that's exactly what I'm going to do. And I'm going to import it into drag loader. And I'm going to use it to kick off this observable. And if you haven't seen this pattern enough to know it's coming, we will exhaust map any response from the dog API. We're going to say, go ahead and animate yourself back home. And the only thing that's left to do is to sort of say, okay, well, if this dies, we need a way to update the source observable for our position. So instead of just using drags here, we can use concat to combine drags, and after drags is dead, because we know it could die if we get past half the window height, let's go ahead and combine that with return after load positions. All right, now let's see if we can get it to fly back home. Dragging down, completes, and heads home. Awesome. Oh boy. It works, but it works once. I can't do it again. Damn. So the thing is this is pretty indicative of development with Rx.js. You solve one problem and you just kind of quickly run into a new one. But here's the thing, try not to think of this as hitting hurdle after hurdle, or you're going to get really frustrated. When you're finished, you'll look back and you won't see hurdles. You'll see kind of obvious now, 2020 being hindsight, stepping stones for transforming and composing your source observables into your desired outcome. So being able to kind of perform that visualization, that path backwards from your destination to your starting point before writing a single line of code, that's a critical programming skill that working with Rx or just doing reactive programming in general helps you develop. So what's going on here? Why does this only work once? Well, again, let's trace through what happens. I started by dragging the drag loader around. I quickly passed the window inner height divided by 2. That killed this whole observable. But before I got there, I did emit a refresh. That's great. By emitting a refresh, I triggered the dog API, which fired, which started return positions happening, which started tween happening, and tween was done once we got back home to 0. And then down here, the thing feeding positions is just drag and return after load positions. So drag's dead, return after load position's dead, positions is dead, transform positions is dead. Game over. Fortunately, Rx does provide a really easy fix for this. There's no limit to how many times you can subscribe to an observable, and Rx provides a very handy operator for bringing everything back to life again, aptly named repeat. So if I just tack on a repeat to the backside of this pipeline right here, I should be able to do this as much as I want. Great. So now I can sit here and play the dog name game all day long. And the last thing I think we actually need to do here is just make the thing spin, make it a little more interesting. We know that the component should be spinning whenever there is an API request in flight. So when you think about it, our starting condition is when we call next on the refresh subject, and our stopping condition is when we get a response from the dog API. So we know we're going to need a refresh subject from app. So let's start by exporting that. And just like the dog API, we'll import it into the drag loader component. And let's create one more observable down here. We'll call it rotations, which will start life based on a refresh signal. We'll pipe one more exhaust map for the road. Any refresh signal will result in a tween animation. That's going to go from 0 degrees to 360 degrees in, I don't know, half a second. Okay. And let's say that we want to stop that from spinning whenever the dog API gives us a response. So that's exactly what that should look like, I think, in practice. And then we're going to do something similar to what we did here using CSS to map this number into a string that makes sense. Instead of transform positions, it'll be transform rotations. And we'll pipe our degree into rotate that number of degrees. an extra S in there. And then just like transform positions, we'll go ahead and expose this to the component. And once again, this time binding directly to the SVG because that's what we want to spin. We will bind style to just be transform rotations. All right, here we go. Sea of red. So if I pull this down and let go, it spins once. Cool. Let's see. So the reason that's only spinning once is I'm tweening between 0 and 360 degrees. I've got nothing to tell this observable to do anything more than do one full rotation. But we just learned and we just saw how to put an observable on loop. So if I just throw a repeat in here, and I'll throw one more operator at the back end, which you've seen before as well, and that's end with 0, which I need to import. And the reason I'm doing end with 0 is because we don't know when the dog API is going to finish. All we, and so that dot could be at the 6 o'clock position or the 9 o'clock position or whatever. And so ends with 0 will just snap the dot back to the top and make it ready for the next one. So, oops. There we go. All right, guys. That's a wrap. That was a lot. It's time to pull that Post-it note off the Kanban board, crack a beer after a feature like that. This was a lot of information in a short amount of time. So I wanted to leave you with some additional resources that I've kind of found helpful for learning RxJS. And yeah, thanks very much for hanging in there with me. And I encourage everyone to give RxJS a spin if you haven't already. Thanks, guys.
Great. That was amazing. That was absolutely amazing. All right.
We'll pull up the chat.
Yeah, I'm going to take over real quick. Yeah. Okay. So we'll have questions and answers. So everyone, you can go ahead and submit on a chat or, sorry, you could in chat. You could submit your questions in chat. You could do the Q&A, or you can raise your hand, and we'll take any questions. And yeah, so I'll just do the questions first. So go ahead and stop sharing. So Chris and Jack. Okay, go ahead.
Yeah, since we don't have anything pending that I'm aware of in Q&A yet, I was wondering, Darren, it was something I had seen a little bit when I had done some Angular development. So you pointed out the RxJS docs and just how many things there are. And even looking at some of your imports, just trying to be aware of which tools to use for which job. Can you describe a little bit about how you get more comfortable knowing this is where I would use take, or this is where I would use take while, and here's where I'll import that from, and that kind of stuff?
Sure. I'll borrow from Ben and say that there are about a set of 10 of the 100 or so operators that are actually the most commonly used. And so kind of starting there, seeing whether or not one of those solves your problem is a dramatic kind of narrowing of your search space. Beyond that, that operator decision tree is pretty good as far as trying to drill down. And then the other thing I guess I'd recommend is at the beginning, don't worry about the operators. That sounds counterintuitive, but sort of like I showed you of, right? And so if you just start to replace things that are imperatively or not reactive with of that thing, just as a starting point, and just get it working, then you can like kind of scratch off the it's working side of things, like I'm rendering the content that I want to the screen, and then you can start to like focus one at a time. And where I would probably start operator wise would be with the set that should already kind of be familiar to you from working with JavaScript arrays, like map and filter and reduce, because the definitions of those things really don't change between RxJS and vanilla JavaScript.
for example, I learned something about array just while watching. Like I had never used array.fill before. So it's cool to see how that all fits together.
That was a disappointing moment for me in JavaScript. There's not a better way to do that. That's pretty ugly. But yeah, I just needed 5 nulls in an array, and apparently, according to Stack Overflow, that's how you do it.
Okay, so we have a question from Andrew Kim that I know during the demo, it seemed like you mainly just reread over your code and used the console, but anything else you normally try? I guess for when you have problems, yeah.
I mean, I would say that sandbox, especially with RxJS, like, Jack just asked a question about, which operator to use. Trying to use that operator as like the 5th or 6th operator in a long chain is not a good place to learn about that operator. Like, take that to a place where you can kind of explore that operator sans anything else and sort of kind of wrap your mind around what it is that it's doing for you in sort of the simplest implementation. So, I mean, for me, there probably are better ways, but for me, it kind of boils down to always having up that sandbox to play in when I sort of run into trouble.
I don't see anything else. Anyone feel free to ask questions, raise your hand, or put something in chat. That was really amazing. I really, really liked the end with the animation and the touch. Like, I had no idea you could do any of that. And now I'm very excited to actually try to do that. That was so amazing. Yeah, that was really amazing.
It's a cool library. I wish that my job was less about putting things into and out of databases and more about having things. But that's the.
But that's why you have to have personal projects, right?
You do, right? I mean, that's kind of why I'm here tonight. This was a really good excuse to get back into it because after leaving Angular for Vue, just kind of didn't see it for a while. So this is
Yeah, I really enjoyed that, and I can't wait to actually try to do that. The touch movement and stuff like that. That was amazing.
Cool.
When this is, so we've been recording this meetup, and as people are aware, which we always talk about, our previous meetups will be posted on YouTube, and you can also find them on the Vue.DC site. Darren, what resources should people expect to be able to find when this is posted, in addition to the recording itself?
That's a good question. I have no problem putting all this up on GitHub. Do you guys have your own code that I can submit to, or?
We can figure that part out. Whatever works best for you. So if the repo's available, that's awesome.
Yeah, I mean, it isn't yet, but I have no problem.
Okay.
So you guys.
That's great. That's great.
And the way that code is structured too is it's got a starting point and an ending point, and sort of a working version that you can just try to get yourself from starting to ending. So hopefully it's helpful for anyone who's trying to retrace what it is that I've done.
Okay, so anything else before we wrap up? Okay, so nothing else. I don't know, Ben, Chris, do you have any questions before I?
No, great job, Darren.
Thanks, man.
Yeah, that was amazing.
Really good, Darren. Great job.
My pleasure. See you guys.
I was also saying that this is a presentation that for sure, unfortunately, Darren didn't get the benefit of actual live laughter because I found it very funny.
we were all laughing.
I'm gonna every once in a while I'm gonna unmute myself next time to just be the soul of some laughter.
We need like a laugh track that we can like play.
We could just play a laugh track.
I felt the good vibes. Well, none of these jokes are landing.